Okay, so now we're going to look at the topic rational and irrational numbers. Before we do this problem, I want to kind of review what each of those is specifically. If you click on these green highlighted terms, a definition will pop up. So we'll look at a rational number. It's a number that can be written in the form of a over b, where a and b are integers. So basically it's saying any number that can be written as a fraction where the numerator and the denominator are both whole numbers. All integers are whole numbers because in any of those cases, you can just put a 1 under it and it'll turn into a fraction. So 7 will become 7 over 1. But the other two that aren't so obvious is anything that has a terminating decimal. That means the decimal stops. So 1.3, there's nothing after the 3. That is also considered rational because you can rewrite it as 13 over 10. It's the same thing as 1.3. So anything that has a decimal that stops. It can be 5 decimal points, but if there's nothing after the 5th one, it's considered rational because you can write it as a fraction. So terminating decimals, because you can always rewrite them as a fraction. And then the last kind is a repeating decimal. So there's a notation. This little bar over the number means that number repeats over and over and over again. So 0.3 with the bar means 0.33333 repeating, and that is 1/3. So that's basically what we're looking for rational numbers. We want to know, can we write it as a whole number over a whole number, or as a ratio of whole numbers? And an irrational number is basically the opposite of that. You cannot write it as a whole number over a whole number. So this definition, a real number is irrational if it is not rational. It is the exact opposite. The easy way with our problems to kind of think about it is, if it's a problem that is a square root but has a radical sign, if it's a perfect square, then it's rational. So for instance, like the square root of 4 gives us 2, gives us a nice whole number. That's a rational number. But if it's something that doesn't have, it's not a perfect square, like the square root of 5, that's not a nice whole number when you take the square root of it. That would be irrational. And then also anything that has a pi attached to it is considered irrational. So let's look at the example. So the square root of 64, that is a perfect square. The square root, well, the negative square root of 64 would give us 8. So that's a nice whole number, so that would be rational. 5 is not a perfect square. So you would not get a nice whole number for that. You get some repeating decimal that cannot be written as a ratio of 2 whole numbers. So that would be irrational. 14.36, this is a terminating decimal. The decimal stops. It doesn't keep going forever. So that is rational. And then we had the repeating decimal. Anything with the bar means it's a repeating decimal and it goes over and over. So this is negative 5.45454545 repeating. So anything with the repeating decimal is considered rational. And then anything that has a pi is irrational because pi doesn't terminate. It's 3.1415 and it continues to go on and on. So that would be irrational. And you can see those answers are correct.